Retrieval-Augmented Generation, or RAG, is a technique that boosts large language models by pulling in external knowledge from sources like databases or the Internet. This helps models like GPT-4 or Llama handle knowledge-intensive tasks more reliably, such as answering fact-based questions or performing common-sense inference. However, traditional RAG systems have a big flaw. They mostly rely on semantic similarity and correlation to fetch information. That means they look for documents or data that match the query based on keywords or topical relevance, but they often miss the deeper causal relationships that explain why things happen. For example, if someone asks why diabetes damages elderly kidneys, a standard RAG system might retrieve facts about diabetes and kidneys, but it could end up with responses that are factually okay on the surface yet misleading because they don't properly link cause and effect. It might say something like diabetes causes excessive insulin buildup, which isn't accurate, leading to incoherent or hallucinated answers. This happens because these systems treat all associations as equal, without distinguishing between true causal links and mere coincidences. To fix this, researchers from the University of California, Irvine, introduced a new framework called Causal Dynamic Feedback for Adaptive Retrieval-Augmented Generation, or CDF-RAG. This approach is designed to make RAG systems smarter by focusing on causal consistency, factual accuracy, and explainability. Instead of sticking with static queries, CDF-RAG uses an iterative process to refine queries on the fly. It starts with an initial question, then dynamically adjusts it based on what it learns from previous retrievals, asking more targeted follow-ups like, "Does diabetes cause kidney damage?" or "How does aging impair kidney function?" Once the queries are optimized, CDF-RAG retrieves not just plain text or documents, but structured causal graphs. These are like visual maps that show the directional relationships between events or factors, such as how high blood sugar from diabetes leads to impaired blood vessels, which in turn affects kidney function, especially in elderly patients where aging exacerbates the issue. This causal-aware retrieval allows the system to go beyond simple keyword matching and incorporate the underlying mechanisms that drive events. Moreover, CDF-RAG enables multi-hop causal reasoning. This means it can chain together multiple pieces of information from different sources to build a complete reasoning path. For instance, it might link diabetes to hypertension as a mediating factor in kidney damage, creating a logical sequence that traditional RAG systems often miss because they don't handle interconnected knowledge well. To ensure the final response is reliable, CDF-RAG includes a validation step. It checks the generated output against the retrieved causal pathways, making sure everything is logically coherent and factually grounded. This helps prevent the model from producing responses that sound plausible but are actually inconsistent or based on spurious correlations. The researchers evaluated CDF-RAG on 4 diverse datasets, covering areas like general knowledge, medical scenarios, and complex reasoning tasks. Their results showed significant improvements in response accuracy and causal correctness compared to standard RAG methods. For example, in tasks involving multi-step reasoning, CDF-RAG reduced errors related to conflating correlation with causation, leading to more trustworthy outputs. This is particularly important in real-world applications where understanding causality can make a big difference. In healthcare, for instance, it's not enough to know that high BMI is associated with heart disease. CDF-RAG could help identify and explain the causal chain, like how high BMI leads to hypertension, which then contributes to heart issues. By addressing the limitations of traditional RAG, this framework paves the way for more robust and explainable AI systems. One key advantage of CDF-RAG is its adaptability. Unlike fixed RAG pipelines that use the same retrieval strategy every time, CDF-RAG incorporates feedback loops, where the system learns from its own outputs to refine future queries and retrievals. This dynamic process makes it better suited for complex, evolving scenarios, such as analyzing scientific data or handling ambiguous user inquiries. The paper also highlights how large language models, trained on vast amounts of observational data, often struggle with causality because they pick up on patterns of co-occurrence rather than true dependencies. CDF-RAG counters this by explicitly modeling causal structures, which helps in tasks requiring deep explanatory power, like multi-hop retrieval where linking related concepts is crucial. In their experiments, the team demonstrated that CDF-RAG not only improves accuracy but also enhances explainability, meaning users can better understand the reasoning behind the AI's responses. This is achieved through the use of causal graphs, which can be presented alongside the final answer to show the step-by-step logic. Finally, the researchers have made their code publicly available on GitHub at the link provided in the paper, so others can build on this work and test it in new contexts. This advancement in RAG technology represents a step forward in making AI more reliable for causal reasoning tasks, ultimately leading to better decision-making in fields like medicine, policy, and beyond.